Okay, as we continue our progress through geometry, we're going to now take a look at some constructions and congruence. So we're going to look at a couple definitions, we're going to look at a lot of examples, and we're going to need some construction tools. Okay. First of all, when we take a look, two different definitions I want to start off with. The definition of similar, meaning like similar figures, okay? Similar objects, similar figures. These are objects which have the same shape, but are not necessarily the same size. With the same shape, but not necessarily the same size. And we will look a little bit more closely at this in a section that follows. Okay? The notation for similar is one squiggle. So that's what it means when you see similar. So for example, let's say I give you equilateral triangles. Okay, equilateral triangles can be similar, meaning I could have this very small equilateral triangle where all three sides are congruent to each other. I could have another equilateral triangle where all three sides are congruent to each other. But when looking at them, they're clearly not the same size. So one of them might be twice as large or half as large, something like that. So these would be considered similar. So if I call this first one ABC, and I call this second triangle DEF, I would say that triangle ABC, so going from A to B to C, is similar to triangle D to E to F. Okay, so they may be the same shape but different sizes. Whereas if we look at the definition of congruence, okay, congruent, if something is congruent, let's do congruent, not congruence, just a different form of the same word. Let's look at congruent. Congruent means they have the same measure. So congruent shapes or congruent figures are objects or shapes which have the same size and shape. Or I'll go in the same order, the same shape and the same size. So the symbol again for congruence, an equal sign with that squiggle above it. Okay? So congruent figures are identical. That means all corresponding sides are congruent. And all corresponding angles are congruent. And we talked about corresponding in the last chapter, meaning that they're in the same location, so they correspond to the exact same location. Okay? And we do have this. CPCTC stands for corresponding parts of congruent triangles are congruent. And we'll look at this again as we get into proofs, but I wanted to introduce it to you at the moment. So we have our C, P, C, T, C. So what I'd like to do first is let's take a look at some triangle congruence. Let's look at a figure or two. Let's list the corresponding parts before we start looking at specific theorems. So let's take a look at some triangle congruence. So today we're specifying triangles. We could have a polygon, but for right now, triangles. So two triangles are congruent if all their corresponding parts are congruent. So we just put that over here, congruent figures. So all their corresponding parts are congruent. Okay. How far can I go? I have a little bit of room left. All corresponding sides and angles are congruent. So we're going to sketch a shape. Okay, we're going to sketch a shape. And for our purposes, we're going to make an assumption that they are congruent. Here, I'll just do this. And let's practice. Okay? So let's say I tell you that you are given triangle ABC is congruent to triangle DEF. Now before I even draw a picture, make note of the order. Notice angle A comes before B, comes before C. And notice the order D, E, and F. Well, that would mean that angle A corresponds to D because they both come first. B corresponds to E because they both come second. And C corresponds to F because they both come third. So I could say automatically just based on location, okay, angle A corresponds to D. So angle A is congruent to angle D because they both correspond. They're in the same location. Angle B corresponds to angle E, therefore they are also congruent. And then angle C came last, so it corresponds to angle F. And since I told you the triangles were congruent, that means those corresponding angles are congruent. And now we're going to do the same thing with the side lengths. The side lengths. So if I look at the sides and I go from A to B and then B to C and then C to A, AB, the first two vertices, would correspond to DE. So side AB would be congruent A to B, D to E. Then on my triangle, if I've gone from A to B, now I'm going to go from B to C. So that would be congruent E to F. And last but not least, the only other side left is the side from C to A or A to C. And make sure you go in the same order. So if I chose to go from A to C, then I have to go in the same order from D to F. So for a visual, I'm sketching this, so they may not be absolutely identical, but I'm going to do my best. That's not too bad, actually. If I call this A, B, C, and angle A is on the bottom left, it would correspond to the bottom left, so that would be angle D. Angle B is on the top. Angle B would have to correspond to angle E because they're both located in the middle. And I'm going to use a different congruence mark. I'm going to use two little marks to show that those two angle measures are exactly the same. And then angle C corresponds and is on the bottom right with vertex F or angle F, and I'm going to use three little marks. So as long as the marks are the same, they don't have to be little arcs like that, but as long as the marks are the same, it means that the measures are the same. And then similarly with the side lengths. A to B, bottom left up to the top, corresponds to DE. BC corresponds to EF. AC corresponds to DF. So therefore, if I know the congruence, if I know the triangles are congruent, all their corresponding parts are congruent. Okay? So now what I want to do is look at a couple of theorems in particular that talk about how you can tell two triangles are considered congruent. So we're going to look at two of them today, and then we're going to look at some others a little bit later on. So the first two, you might remember if you took high school geometry. I'm not asking you to remember how to do it, but it might sound familiar. So we're going to look at two theorems. And remember, a theorem has been proven true. And once you prove a theorem true, you can use it forever. So for now, we're not going to be proving them true. We're just going to be using them. So the first triangle congruence theorem. Now we're looking at triangle congruence, so we're still talking about triangles, is what's called side-side-side triangle congruence theorem. And I will accept SSS. So that stands for side-side-side congruence theorem. And what it says is, these are theorems, so these are if-then statements. These are conditional statements. So the hypothesis says, if three sides of one triangle all right, three sides of one triangle are congruent respectively to three sides of another triangle, then the triangles are congruent. Respectively. Respectively. I'm so sorry. Respectfully. I was thinking about something we were doing today. Respectively, meaning if they're in the corresponding location. Respectively. If three sides of one triangle are congruent to three sides of another triangle, then the triangles are congruent. that's very similar to what we just showed over here. If all three sides are congruent to their corresponding parts, then triangle ABC is congruent to DEF. Then we also have SAS. Triangle congruence theorem. And you may remember what this one stands for. And if you don't, that's fine. You may, from our Euclidean geometry, this means side angle side. And notice where the angle is located. The angle is located between the two sides. So if you have two sides and an angle between them, okay? So if you have two sides and the included angle of one triangle are congruent to two sides and the included angle of another triangle, then the two are congruent. If two sides, and notice again where the angle is located is between them, and the included angle of one triangle are congruent to two sides and an included angle respectively. Then the triangles are congruent. So let me give you an example of what each one might look like. So let's say, for example, I give you the following. I give you a triangle. There's another triangle. It's a little bit off, but I think it's good. And I call this triangle A, B, C, and D, E, F. And I tell you that this triangle, side A is 4 units long, side B is 5 units long, then side C is 7 units. And I give you the same measurements, the same length on another triangle. Well, I could use congruence marks and say, well, it sure looks like AB is the same as DE, so those are congruent. BC is the same as EF, so those are congruent. And they're different than 4, so I'm making a different mark. And side 7 units long is different than 4 and 5, so its congruence mark is different. I can see that those 3 sides are the same. So I could say, by the side congruence theorem, and I'm fine if you just say side, triangle, and now pick an order. If you choose to go from A to B to C, you must write it in the corresponding order. So A to B had 1 mark, and then B to C had 2 marks, and then C to A had 3 marks, so I have to go in the exact same order. E has 1 mark, E to F has 2 marks, F to D has 3 marks. So I have to write them in the same order. I'm so sorry. This is angle F, vertex F, if you cannot see that. Okay, so it's vertex F. Okay. Side angle side. This one, maybe I have something that looks like, we'll make it obtuse. And I'll call this URS. URS TVW. They don't have to always be alphabetical. And I'm going to tell you that angle UR is congruent to TV. I'm going to tell you angle R is 100 degrees. Angle V is also 100 degrees. And I'm going to tell you those other 2 sides are the same. And so if we look at the order, notice the angle R is between the 2 sides that have been marked. Angle V is also between 2 corresponding sides that have been marked in the same way, respectively. So I could say, I could do it this way. Triangle URS is congruent. You fill it in. And I would say by side angle side theorem. And then we also have a theorem involving a right triangle, and it's called the hypotenuse leg theorem. Hypotenuse leg theorem. Which says if the hypotenuse and one leg of a right triangle is congruent to the hypotenuse and a corresponding leg of another triangle, then the 2 triangles are congruent. If the hypotenuse and leg of one right triangle is R, congruent to the hypotenuse and corresponding leg of another right triangle then the triangles are congruent. So that's called the hypotenuse leg theorem. Hypotenuse leg theorem. So a picture of that might look like the following. Let's do a pretty standard looking right triangle. And let's say I have another pretty standard looking right triangle. Well, the hypotenuse is always the longest side. It's always the side across from the largest angle. So if this is the 90 degrees, which is the largest angle, here's our hypotenuse. And then all I need is one corresponding side. So I'm going to choose this particular side. So if I rotate this angle and I rotate this triangle around, I would say that these two are congruent by the hypotenuse leg theorem. Okay, and that one's actually proven by Pythagorean theorem. All right. Okay, so before we start looking at some constructions, let's take a look at specifically isosceles triangles and look at two theorems that go and are directly related with isosceles triangles. All right. See how we're doing here. So let's take a look at a couple of isosceles triangle theorem. Isosceles triangles and their theorems. Now, if you recall, an isosceles triangle has two congruent sides. So if this triangle is isosceles, I would know that by making two congruent marks. And so we have a couple of them. So the definition of an isosceles triangle is any triangle with two congruent sides. Now, we also have something on these triangles. If these two sides are congruent, the angles that created the side, these are called base angles. Okay, so those are the base angles. So our first theorem was what's called the base angle theorem. I don't think your book calls it the base angle theorem. But if we use the vocabulary, it's a little bit easier. The base angles are the angles that created those congruent sides. So the base angle theorem says, if a triangle is isosceles, then the base angles are congruent. And then we have the converse to the base angles theorem. And a converse just says you state it the other way. So we also have the converse to the base angle theorem. You might remember from last class, you had converse, inverse, contrapositive. So the converse is just when you take the hypothesis and conclusion and you reverse them. So the hypothesis is if a triangle is isosceles, and the conclusion is then the base angles are congruent. So the converse will say if the base angles are congruent in a triangle, then the triangle is isosceles. If the base angles of a triangle are congruent, then the triangle is isosceles. And now what we want to do is we want to practice using some of these, but we also want to practice some constructions. So the next probably 15 minutes is going to be actually starting to use some constructions and do some constructions. So I did put in the module a handout if you have a printer. If you do not have a printer, you can follow along by creating your own line segments. All right, so we're going to look at some constructions. So the second part of this is constructions. Now, when you're doing a construction, okay, you must use two tools. So we have two tools, construction tools. Oops, the board's still wet, I apologize. Construction tools. One, you need to have a straight edge. That pen is too wet. A straight edge is anything that makes a straight edge. It does not have to be a ruler, okay? You can have a ruler, but you could use the side of a pen. You could use the side of a piece of paper. You could use the side of a pencil box. You can use anything that creates a straight edge. And the other construction tool you need is a compass. Those are the only two things. And when we do constructions, you leave the marks on the paper. A compass. Okay, a compass is what you use to make a circle. If you do not have a compass, and it's hard for me sometimes, I'll be honest, because this whiteboard gets very slippery. So sometimes you'll also see me create a compass by tying a piece of paper, by tying a string rather to a pen, and then I can hold it down with my thumb and I can create a circle by using that pen and going around. So you can use a piece of string, dental floss, a shoelace, a cord of some sort, something that's not stretchy. Don't use a rubber band. Okay? And so we're going to start with a few basic constructions. Now, if you download and make a copy of the handout that I have given, where am I? Copy a line segment. I'm going to not only provide, I'm going to provide directions for you in case, because I'm going through it, but there it is. Okay, and I've got a template for the notes, which I will also upload for you so that you can take those notes that I just went through and put them on that template. Okay, so the first construction we're going to do is how to copy a line segment. Okay, so to copy a line segment. So we're going to practice this together. Now again, I have for you some construction notes that you can, I think these are all, okay? I will provide these in the module so that you can actually practice them on the paper if you have a printer. Otherwise, you can practice on your own paper. So here we go. Okay. So here's the, we would like to copy, so I'm going to give you the givens in black, and we'll do all our copying in blue. So let's say I give you this line segment, and I want you to copy this line segment from A to B. Now remember, you do not have a ruler, so you cannot measure it. No ruler. Okay, so to copy line segment, we're going to copy line segment AB. So here's what we do. First of all, we're going to take, and we are going to, I'm just going to use my compass or pen, we are going to create a line segment that's longer than what we need. And I am going to label this side A, or actually I'll label it C. Okay? Now remember, I cannot use the ruler marks to measure how many centimeters or inches. I'm going to use my compass to do that. If I actually open my compass up, I'm going to put one end of the compass on A, and I'm going to open the other one all the way up to B. So do you see how long that is? I'm going to make a little mark. I'm going to do the exact same thing. I'm going to put this on one side, and I'm going to make a mark. I don't know if you can see that pencil mark. So I'm going to copy the line segment by putting one side of my compass down, transform that to corresponding parts, make a little mark that's the same length, and I'll call that point D. Now that I've copied it, I know that those are congruent because they're the exact same length, and therefore I've copied an angle, copied a line segment. All right, let's take a look at in the second construction. Let's bisect a line segment. So the first thing I'm going to do is I'm going to give you a line segment. Again, it does not matter how long it is. So if you do not have the notes template that I provided for you, you can create a line segment on your paper. Give yourself some space. Now to bisect it, I'm going to create a perpendicular bisector. Okay? This also creates a perpendicular bisector. To bisect means to cut in half. So what I'm going to do is I am going to make sure that I open up my compass more than halfway. More than halfway. If I only open it a little bit, I'll never get to the midpoint or halfway to bisect it. So I'm going to open it up and make sure it's definitely more than halfway. Now again, this slides a bit, so I'm going to do it with the other compass that I created. But I'm going to take this, I'm going to swing an arc from both endpoints. Okay? I'm going to swing this arc from both endpoints, keeping the compass open the same amount. So I'm going to take my compass, definitely go more than halfway. I'm going to swing an arc, keeping it exactly the same measurement from the other side. I have to switch hands. I am going to swing an arc. You'll notice that they intersected each other. I'm going to take my straight edge, line up those points of intersection, and if I line up these points of intersection, mine might be a little off because mine slips on the whiteboard, but you'll notice this line is now perpendicular and it bisects it. How do I know? You could measure it with your compass. If I go from one end point to that point of intersection, that should be exactly the same as if I come from the other end point to that point of intersection. So now these two segments are congruent. So I now know A to C is exactly the same. Measure, therefore they're congruent. So you just swing an arc. So now we have created a bisector, we found a midpoint, and we've also actually created a perpendicular. So we've done a lot in the same thing. Now let's talk about, we now have looked at how to copy an angle. We've looked at how to copy a segment. We've looked at how to bisect that segment. Let's do the same thing with an angle. Let's first copy an angle, and then we'll bisect the angle. So let's first start with an angle. Copy an angle. So maybe I'll start with angle ABC. I'm just going to create an angle here. And we called this angle ABC. So I know that's the intersection of two rays. So here's here's point A, vertex B, point C. And I want to copy that. So I want to create, without a protractor, without a ruler to measure the sides, I want to copy that angle exactly. So what I'm going to do is I'm going to start with my straight edge, and I am going to create a line segment longer than I need. Okay? And I'm going to call this point ABC. We'll call this D. Now the first thing I'm going to do is I'm going to open up my compass, and I am simply going to swing an arc on my original. It does not have to go through one of these points. Here, I'll shorten it. It just has to intersect both sides. And I'm going to take that down, and I'm going to do the exact same corresponding angle. Now mine slips a little bit because it's not locked in. Now that I have that, and I guarantee that this side length from here to here is exactly the same, now I'm going to measure how wide the angle opens. So I'm going to put my compass down. I don't know if you can see me. I'm going to put my compass down. Okay, I'm going to open it up to however wide that angle is. And I'm going to take it, and I'm going to put a corresponding, and I'm going to make a mark. Okay, it's the same as opening this up. Bring it down here, make a mark. And now that tells me exactly how far I'm going to go from my vertex through the intersection of those two little marks I made. See my little mark right there? That shows me how wide that was. And now I have copied the angle. And I leave all the construction marks. I leave the fact that this is longer. I leave the arc in here. And I may now call that angle EDF. Okay? So what I want to leave you with is that, so I wanted to copy the angle. And now I wanted to also bisect that angle. And then we'll practice, and we'll practice, and we'll practice, and we'll practice. We'll practice on the lab. So last, let's bisect a given angle. Okay. So I'm going to start with an angle that I give you in black. Make this a little larger so you can see it. Whoops, slipped a little bit. Sorry about that. These whiteboards are so slippery. So here is angle A, B, C. And I want to bisect this angle. I'm not using any measurement. I'm not using a protractor. But I want to bisect this angle. So what I'm going to do first is I am going to use my compass to swing an arc that intersects both sides. Okay? Then I'm going to pick my compass up, and I'm going to go to one point of intersection and swing an arc out here somewhere in the interior. Don't change anything. Pick up your compass, go to the other point of intersection, swing an arc so that it intersects in the interior of that angle. So I'll do that again. I'm going to swing an arc from each of these points of intersection. I'm going to swing an arc on the interior of the angle. Swing an arc on the interior of an angle. Notice it created an X on the interior of an angle. If I connect that point of intersection to our vertex, I'll get my fingernail, sorry about that. You'll notice that I have now created two congruent angles. Therefore, since they are both congruent, this angle has been divided in half. Therefore, it has been bisected. All right? So again, if you have an opportunity, download the templates that I put in the module, kind of walk through those, and we'll look at some more constructions in the next section.